Let me introduce myself. My name is Ranu Bopanna. I'm not Ravi Bopanna, not the founder of this competition, but he's my husband. And I'm also an MIT alumni. I'm not a mathematician, I'm a medical doctor, but I very much believe in this cause. Like a lot of our volunteers, we really believe this is much more than a competition. This is really about creating that energy, that positive energy for our girls to succeed in math. Your girls would not be here today without your support and encouragement, and that's the reason that we bring you all together. MIT does a wonderful job of welcoming us every year. I can't think of a better place to have this event. And let me introduce you now to our speaker, Richard Rusczyk. I think he's very well known to many of you. I saw a lot of photographs being taken earlier. Richard is the president and founder of the Art of Problem Solving and has devoted his life to promoting mathematical problem solving, as well as creating opportunities for gifted math students. Richard himself was the winner of the USA Math Olympiad in high school. He went on to graduate from Princeton. He worked briefly at D.E. Shaw before he realized that his true calling was in educating gifted math students. He went on to found Art of Problem Solving and the Art of Problem Solving Foundation. Many of your daughters might have read one of his 7 books that he's authored or co-authored. In 2012, he also won the Math Counts Distinguished Alumnus Award. And just a few months ago, he won the Paul Erdős Award from the World Federation of National Math Competitions. Richard's going to talk to us today about the resources and opportunities for bright mathematical students outside the classroom. And while he's speaking, I'll also be passing out index cards for you to write down your questions, and we'll have a brief Q&A afterwards. So please welcome me in joining the very talented Richard Rusczyk.
Thank you. Everyone hear me fine? Oh yeah, you can. Excellent. So I'll start off by talking a little bit about why we bring our children to events like these. And one of the real, I'm guessing one of your goals is to help these young women lead rich, fulfilling lives so that they can achieve their goals. And one of those goals is for them to achieve some measure of independence and get them to move out of the house. That would be nice. Now, the way I formulate this when I'm talking to the students is that they want to get somewhere where nobody gets to tell them what to do. That formulation is very popular with the kids, not as popular with the parents, but that is a bit of what we're talking about, is that these students, they want to get to a position where they can pursue their goals without people obstructing them, or hopefully with people helping them. Now, the keys to the independence, if you look back over time, 2,000 years ago, in order to achieve this level of independence, you had to only be good at one thing, just one thing, and that was choose your parents. All right, you chose your parents well, you were going to be fine. You know, you chose Caesar. Nobody was going to tell you what to do except for Caesar, and eventually you'd be Caesar, and nobody was going to tell you what to do. But if you didn't choose your parents well, as almost everybody did, almost everybody had very rough lives if they weren't Caesar 2,000 years ago. Now, if you fast forward to 200 years ago, well, you could still choose your parents. That still worked. You chose king and queen, duke or duchess. You were going to be in a position where not many people were going to be able to tell you what to do. You were going to be able to be fairly independent. But if you didn't choose your parents well, you did have another option 200 years ago. You could pitch it all and go west. And I'm looking out at this audience. You probably went east. And that's a very good thing. We're very happy you're here. But this required a lot of bravery. It required a lot of luck. And you had to give up an enormous amount to go somewhere where there wasn't already a bunch of people where you could build your own life. Back then they didn't have Skype. They didn't have iPhones. You couldn't stay connected to your family. You had to give up absolutely everything, never see them again. And nowadays you can't even do this, right? There's nowhere you can go where you're not surrounded by a crowd of people, where there aren't already structures in place, where you don't already have to work through a thicket of things in order to live your life the way you want to. So the question is, how do you get to that point? How do you get to that point where you can really be independent and make your own way? What are the keys to independence now? Well, choose your parents. That still works. Got something there for the ladies, something for the men. But now what's the other option? You can't just pitch it all and go west. Now the key option is to develop your mind. Because nowadays, the frontiers, they're all intellectual. They're not physical. And even the physical frontiers, the bottom of the ocean and outer space, even those are intellectual frontiers because they don't send dummies into outer space, no matter how much we'd like them to. So all the good stuff, all the frontiers, all the places where you can go out to the edge and really explore and find new things and make your own life, all these frontiers are intellectual. And the people who shaped the world in the past, their titles came before their names. They were presidents, they were generals. The people who are building the world today and the people who will build the world tomorrow, their titles come after their names. They're PhDs, they're CEOs. So now the question, of course, is, if this is where all the action is, out on the intellectual frontiers, how do kids get there? How do we get these kids out to these edges where they can really explore and build a wonderful world for themselves? What you hear in school is get A's in all your classes. But is that enough? And the fact that you're here means that you've already answered the second question. You know that it's not already enough. Now, I got a great answer, or a great example of why this isn't enough. Right after I started Art of Problem Solving, I received an email from someone that went to Princeton around the same time I did. And he wrote, "I certainly wish your website and materials existed when I was in high school. I went through junior high and high school without ever missing a question on a math test. And then I took Math 103 and 104 at Princeton, which was one of the most unpleasant and bewildering experiences of my life and poisoned me on math for years." Now, I want you to think for a minute what this student's middle school and high school teachers thought when he went off to Princeton. They thought, we succeeded. Look what we did. He went off to Princeton. We're awesome. They never saw this, because I'm sure he didn't go back to his middle school teachers and say, "Yeah, what's up? You didn't prepare me for this." So they didn't get this feedback. And this happens a lot. I saw this a lot at Princeton. It happens a lot now. The kids go through school, even very good schools, they get perfect scores in everything, and then they come to a place like this, place like MIT, place like Princeton. They walk into that first year math class and they see something they've never seen before, problems they don't know how to solve. And they completely freak out. And that's a bad time to have these first experiences of having to overcome initial failure. Now, what happened to this guy in school? And this is why school isn't enough. First of all, the problems aren't hard enough. Right? The regular curriculum is very easy all the way, for these kids, it's very easy all the way up through calculus. Even the dreaded BC calculus test, it's going to be easy for all these students. You could give me a room full of these girls who haven't taken calculus yet, put them all in a room, give me a few months working with them, and I'll teach them in Polish. All right? They don't know Polish, and despite my last name, I don't know Polish. And they will still get 5s on this test. And the reason is because they're great pattern matchers. That's part of their intelligence. They can pattern match, and that's all they're having to do in their classes is see the pattern, see the pattern, see the pattern, match it at the end. All their homework looks exactly like what their tests are going to be like. The numbers are just changed. Even the AP test is like this. The thing is, we don't want to train them to do that because that's what these are for. Right? We have computers to do that, and they're way better at it than we will ever be. They're also very good at memorization. They're much better than we are, and as we all know, as you get older, that memorizing thing just isn't going to work, right? Because that gets much worse and worse and worse, and these are even better at it than we are, than they are at the pattern matching thing, and than they are at the repetition. But that's how you can easily get through school. Just memorize the trick of the week, do it on the test, move on. And there's also, with the advent of computers, there's a real hole in math education. Math education is focused on algebra. And most of the standard classroom is algebra, 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 a little bit of geometry, algebra, algebra, calculus. And then you're educated. And these computers, they don't speak calculus. They speak in discrete math. They speak in a different mathematical language. But the topics of discrete math, your counting and probability, your number theories, they maybe get a couple weeks coverage over 6 years in a typical school classroom. But people need to learn how to speak to these because we're all going to work for them someday. So we need to know their language. Now, you hear all this stuff, STEM education is so important, STEM education is so important. So you'd think these things are going to change, right? That eventually, the system is finally focusing on this problem. They're going to get these students to a place where they're going to be able to be the next generation of scientists and engineers. Well, Art of Problem Solving applied for a grant from the Department of Education once, and this is the response we got from one of the reviewers. While challenging and improving the mathematical problem-solving skills of high-performing students are surely everyday objectives of those who teach such students, it is not a problem, relatively speaking, of major import in American education. Now, this is a really shocking statement. I want you to imagine taking one adjective out of this sentence and replacing it, high-performing, that one right there. Replace that adjective with any other adjective. Put female in there. Could you imagine someone in the Department of Education writing this sentence with the word female there? Or any ethnic group you choose, put it right there in place of high-performing. You could imagine the reviewer typing this and seeing his career flash before his eyes. But he's perfectly comfortable putting high-performing, putting your students here. Your students, not of major import. Really shocking. And this is at the Department of Education, so this is the system that the teachers are working within. So even the teachers who are equipped to and really want to serve these very high-end students have their incentives set up so that this is an issue that's not of major import in American education. So the question is, what do you do? Now, if you go to the schools and you push hard enough, if you can get them past nothing as the thing to do, the first thing you're going to come up with is acceleration, right? And many of your daughters are probably accelerated in school, but that alone is not going to solve the problem. Because what's the problem? When you have Janie in a 6th grade math class and she's bored to tears. Why is she bored to tears? Because that 6th grade curriculum is written for an average 6th grader. But Janie's not average. So what do? They pick her up and they move her into a 9th grade classroom. But she's still bored, because now she's in a 9th grade classroom where the materials are written for the average 9th grader. But the problem is Janie's still not average. And the average 9th grader is not the same thing as a really bright 6th grader. These are not the same set of people. It's not going to be until Janie gets well into college that the average person who's still studying math looks like her. So there, the materials that are for the average student actually are pitched at her. But all through the standard curriculum, all those materials that are written for the average student, doesn't matter what grade, they're not written for her. Because what they're written for is doing very simple problems. All the way through the curriculum, the problems are easy. They're one-step problems. They might be more advanced tools in the later grades, but the problems are still easy. So moving her from the 6th grade to the 9th grade classroom doesn't give her harder problems to solve. It just gives her more advanced tools. And she's good at picking up new tools. She'll use those tools and still have these trivial little problems to solve. But what we need her to do is we need her to learn how to solve problems, difficult problems that she's never seen before. And this is what I call a problem-solving education. It's taking simple tools and solving difficult problems that you haven't already seen before. Now, I didn't really appreciate the value of this sort of thing, things that I learned from these math competitions until I went to college. Now, when I was in high school, I went to a very average high school. I went to high school in northern Alabama. Our graduation rate was 65%, maybe 10, 15% of us went to four-year colleges. This was kind of an aggressively average high school. And I was a little worried going off to Princeton that I'd be competing against people that went to the Exeters of the world and the Thomas Jeffersons and all these really fantastic schools. And I found something really interesting when I got to Princeton, and I saw it very, very quickly, was that those people had to worry about me because I had training they didn't. I had sat in front of math tests that had 4 problems in 5 hours and not known how to do any of the problems when I started, and a few times not known how to do any of the problems when I ended either. And that was a painful experience at the time, but it was a very valuable experience because I had learned how to deal with the challenges you're going to see at a place like this. You know, they don't want to teach you how to do the same thing over and over again. They want to teach you how to discover new things. And that means you have to be confronted with challenges that are unlike anything you've ever seen before and learn how to find ways to relate these new challenges to things you already know how to do and start to tie these things together, broaden your knowledge. And all these students, even the ones at the very good schools, a lot of them had never faced challenges like this. They hadn't been through the experiences I'd been through. And the experiences that I'd been through translated. It wasn't just my math classes that were easy. My chemistry classes, physics classes, econ classes, computer science classes, all of them were pretty easy because I had already crossed this river. And a lot of my classmates hadn't. And I saw a lot of them do the same thing that guy who sent me the email did. They quit. They gave up on math, they gave up on science, and the minute you do that, doors start closing. And it wasn't because they were stupid. It's just because they hadn't had the same experiences I did. Plenty of those people still struggled through those experiences. They had a rough first year, but now they're leading scientists in their fields. But a lot of them dropped out. And imagine how different the world might be if they hadn't. How different their lives might be if they hadn't. And this gets even more extreme when you move on to careers. Now, when I look back over all the things I've done since I left college, I realized that virtually none of those roles existed when I was in high school. So what could my teachers possibly have taught me in high school to prepare me for my careers? Now, if they sit there and said, okay, here's the specific skills you're going to need for this career, maybe that approach worked in 1940, but it doesn't work now. And it's even more extreme for your children. Because the jobs they're going to have, almost none of them exist now. And even the names might be the same, but what they're actually doing is very different. Like what we call a doctor 20 years from now is going to look very different than what we called a doctor 20 years ago. And this is going to be true all across every single profession. And of course, there are going to be lots of professions that just don't exist at all right now. So how do we prepare students for that? We don't know what the skills are that are needed, but we know one general skill that is very much needed, and that is the ability to learn new things. The ability to be confronted with new challenges and overcome them. So now once you've decided you want to try to work on this problem, to solve this problem, to help your child develop these skills, you're going to run into some problems. You're going to run into some other challenges. First, you're going to have to convince the schools there's a problem. Because they're all looking at these kids, they're all looking at your kids the way those teachers must have looked at my classmate at Princeton. They're getting A's, that's good enough. And you have to help broaden their perspective to get them to realize that these kids are not later in life going to be competing to just be the best in that school or in that town or even in your state. Eventually, they're going to be competing with the best in the world. And the stakes are really high now. The stakes are really high because you can see this on the internet. It's very much a winner-takes-all world for a lot of these disciplines because the top people can command a lot of resources through technology, and we'll talk more about that later. So you need to set these kids up to be competing and participating. I mean, even if it's competing or cooperating, either one, you need to be working at that level of the best in the world, not just the best in your school. So you need to broaden the school's focus. Now, when you try to do that, you're going to run into equity issues. And you probably have run into this with your schools already, where you go in and you ask, I want my daughter to be able to do this. And they say, well, if we do it for her, then we have to do it for this person, we have to do it for this person. And that answer, I mean, it should be easy to answer if they would just listen, which is, if that other person deserves it, they should get it too. Right? I mean, that's equity, that's fine. And yes, there are going to be students who don't deserve it, and then they don't get it. We do this in all of our sports teams. They don't let 73 people join the basketball team. 12 do. The 12 who deserve it. The 12 best players make the basketball team. They've earned it. So the equity issues should be, yeah, the students who deserve this and earn it, they should get it. And then another big problem you face is convincing the students there's a problem. I'm getting A's in school. Why are you bugging me? I'm sure some of you parents have heard some of this. You've solved that problem to some extent by bringing them here. The best way to solve this problem is to get the students around other students who are very good at things that they want to be, that the students themselves want to be very good at. You know, when I first started going to math competitions, one of the most shocking things I saw was kids who knew way more math than I did. And that was really, really surprising because, of course, you know, I was 12, I was the smartest person in the universe. And then I go to these contests and I meet these kids who can do these amazing things. And some of them, after I'm around them for a while, I realize they're always going to be able to do more amazing things than I can. Maybe that's okay. I'm just going to make sure they're on my team. which was a valuable lesson for later in life when I would start hiring people. So now I want to transition a little bit and talk about some general strategies within middle and high school, and then we'll talk a little bit about college later for how to introduce some of these concepts and train these students in some of these ways. I'll start with extracurricular programs like this one we have right here, and these usually start with a math club. So probably a lot of your daughters are in math clubs or on math teams now, and this is a place where the teachers or the students themselves get to break outside the standard curriculum. Once you're into a math club, into a math team, there aren't any state tests to prepare for. There's none of that. Here's where the teachers and the students can do something actually interesting and something more powerful and something that's going to help them later. A second and more subtle one is letting these students know that this stuff is really important. When you're in middle school, you hear all the PA announcements and you see all the stuff on the walls about the basketball team and about the football team, and you'd be forgiven for believing that, well, that's what's really important, because that's the stuff people are celebrating. There's nothing special for the math people. There's nothing special for the writing people or anything like that. Having the math club starts to help change that a little bit. You're special enough that we'll at least give you a little time to indulge in this interest. Because when you're in middle school, you don't see how cool this stuff is. And by cool, I mean how society views it as cool. Because nobody views it as cool when they're 12, right? I mean, some of the kids do, but as a group, as a society within the middle schools, they don't necessarily accept that very special schools view math and computer science is cool. And the kids don't see the job listings, right? They don't see the top 10 job satisfaction, top 10 pay. It's geeks top to bottom, right? I mean, these are my people. I love it. You see those lists, but when you're 12, you don't see that. You don't realize it. It's not until you start to get to, even the beginning of high school, it's still not cool. By the end of high school, the kids start to realize who's going somewhere. The geeks are going somewhere. And the geeks start to get cool even by the end of high school. You can't believe that when you're in middle school, right? You can't believe it when you're a 12-year-old who really likes math and computer science, that by the time you're 18, you'll be cool. And that by the time you're 22, you'll be really cool. So, because, once you get out of college, it gets even better, right? Because everybody's looking for you. They don't want the high school quarterback anymore. They want the geek. Because we can do things. And in that club, you start to build a culture for these kids. It's the culture that they're going to live in 10 years later. And this culture is extremely important. It's the culture you try to build in your homes. This culture of push yourself, try to become the best you can, work well with the other people who are really good at things. This is what you're trying to do at home. When you put these kids together, they build that culture themselves. I saw it last night at the games night, and you just see all these young women together, just laying on the floor, working on math problems, sitting on the stairs, singing Phantom of the Opera. I got to tell you, that would never happen at a boys' prize for girls. A boys' prize for girls, there you go. Math prize for boys, there you go. I got to be careful up here. And then also these events, they provide a social interaction. So these girls, they're going to meet each other at this competition, and some of them are going to form friendships that are going to last their whole lives. Most of my closest friends are people that I met through these competitions. And after this, I'm going to get on a train and go down to New York and spend the rest of the weekend with Chandra Lahosky, who is my co-author on the original Art of Problem Solving books. And he was someone that was probably my fiercest competitor in high school. We were not friends for the first couple years we knew each other. That was because I beat him over and over and over again. But that's only because I'm a year older. I do remind him of that every once in a while because he has to be reminded. But seriously, for a lot of these people, they're kind of alone in their schools. And I saw that the first time I came to the Math Prize for Girls. When I first came to the Math Prize for Girls, and I gave this talk, that was, I don't know, how long has it been now? 6, 7 years? How long is this competition? It's been a while. And I was a little skeptical about it. I was thinking, when I was a student, I don't know how I'd feel about a competition that has, $40,000 in scholarships and I can't participate. I'm sure I'd want to go visit and everything, but I would want to participate. So I went to the awards assembly afterwards, and I met this young woman. She was from West Virginia. And I said, oh, so you like math competitions? And she said, no, I don't like contests. I was like, oh, okay. So you're here to meet, to see some of the other women that you've worked with online or met at summer camps. And she said, no, I don't know anybody here. And I'm like, okay. Then why did you come here? You don't like competitions, you don't know anyone here, why did you come? And she said, I've never seen another girl who likes math. I'm like, okay, I get it. This is a very good thing. So this is a place where they can start to build those bridges and start to realize that, yes, this is cool. Because this is very much the world that they're going to live in for the rest of their lives. It's not going to look anything like their middle or high schools unless they're at very special schools. So now I'll move on and talk a little bit about competitions. I mean, almost everybody knows about math counts in middle school, AMCs for middle and high school. And obviously we all know about the Math Prize for Girls. Some of the others on this list focus a lot more on teamwork, which is something I know a lot of these participants, they like to work with each other. And then like the USA Mathematical Talent Search, that removes the time restrictions. So another thing that some students don't like about math competitions is the timed aspect, the time pressure. The USAMTS, actually the Art of Problem Solving Foundation runs that now, and the students have a whole month to work on a set of problems, and they have to write full solutions. So they start to do some mathematical writing. And then there are university contests, basically kind of all over the country, and that gives you a chance to experience the college like they're doing today. Now, for students who really aren't into math competitions, there are math circles, and these are scattered all over the country. And some of the math circles have competitions as their focus, but many of them don't. And typically, these bring together students once a week or once a month to explore different areas of math. And they have instructors from the community, often professors, who are very mathematically sophisticated, typically much more mathematically sophisticated than you'll find in the average middle or high school. Now, next I'll move on to talking a little bit about independent study. And by independent study, I simply mean something that's unstructured, that isn't, here's the test, here's the clear assignment. Now, one of the biggest values of this is the world that most of us operate in. First, a little bit in college, where the goals start to stretch out and become a little bit more long range. You don't have homework every day. And then in careers. Most of us that are in careers where we don't have homework every single day. We have a lot of long-range, kind of ill-formed goals that we have to figure out how to go after. My goal is to make smart kids smarter. Well, how do you do that? There's not a, here's 10 problems to solve every night way to do that. You have to figure out the path to get to that. And this is what independent study will do for these students. They'll have some kind of vague goals, and they'll have to figure out what the path is to go after them. And it also takes away the ceiling, that 100% ceiling, you've got it all done, that you have in the classroom. It gets away from that, I'm getting A's, isn't that good enough? It allows the students to redefine where that ceiling is and put it much higher. And it allows them to go find the resources that speak to them instead of the ones that are produced for everybody. So whenever anybody tells me I've got the answer for everyone in education, I immediately start to think this person is wrong. Right? Because I don't believe in the answer for everybody. I don't think it exists. I think giving people lots of resources and floating towards the ones that work for them is a much better way to go. By doing all this, of course, we make them more mature. They find better ways to approach problems, and they find ways to do it themselves rather than counting on somebody else to tell them what to do. Because if they have to count on someone else, when they get out into the careers, if they need someone else to tell them what to do, that's going to put a hard, low ceiling on how far they can go. And this is going to teach them how to create their own avenues. But most important is time. You see this now with your children. They're way oversubscribed. I was on an advisory panel for a website that was supposed to build a website for very high-performing students, and they had this advisory board of people who had done really impressive things in various areas of math or science, and they had a handful of educators like myself. And I was in a little breakout group. There were 10 or 12 of us in the room, and it was me, and all the rest of them were in some sciences or robotics, mathematics, something like that. And these were people that had done really amazing things. And we were told that we were supposed to come back to them and give them a recommendation of what would be the most important thing they could accomplish with this site. So naturally, we didn't agree on anything. right? You got these 12 people who are all very used to being listened to, and nobody really had any common ground of let's do this is important. So then I asked a question. I asked them what was important to them when they were in high school. And we went around the table and talked about it. And it was very clear that there was one common thing for all of them, was that the most important thing that happened to them in high school happened in their free time. It may have been started by something somebody said in a classroom or in a summer program, or while they were taking a college class when they were in high school, or something like that. But the most important time they spent developmentally in high school was time spent on their own. Every single one of them. And it was definitely true for me. You've heard me talk a little bit about what my high school was like. I had a lot of free time, and that was awesome. That was a great education for me. And that's one thing as parents, if you can do that for your kids, it's a huge benefit to them, is to remove obstacles, clear out some time, and let them go after the things they really love. Because one thing they have to get very good at is getting very good at something. I don't even care what it is, really. I mean, we'd love for it to be math science related, but it can be ping pong for all I care. I mean, obviously we want it to be math science instead of ping pong, but still the experience of getting very good at something, that experience translates as well. You learn how to structure yourself, how to structure your time, how to focus, these sorts of things. The students don't have time to do that. These students, they're very smart, they can get good at things, but when you pack their days with all this sorts of stuff, 7 AP classes, 3 extracurricular activities, and the school play so I can get into Fair Harvard, they can get good at all those things, but they can't get very good at any of them. The very good, that comes from more time, more focus, and removing some of these other distractions. Now, one place you can get inspired to do independent study in certain areas is through summer programs. So if you're interested in math, here's a list of a bunch of different math summer programs that these students might apply to. They all have different focuses. Some are very focused on math competitions. Some of these are, couldn't care less about math competitions. Some are highly structured, regular assignments during the camp. Some are very free-form. They're much more like camps. The kids can go to classes or they can choose not to go to classes. We'd like them to go to the classes. So there are a couple other big considerations if you're going to think about sending one of your children to these. The 2 reasons that I hear most common for students who didn't like a summer program, the first is their age. They were too young. So if a camp says high school, they don't mean middle schooler studying high school math. They probably mean high schooler studying college math. Take the age ranges seriously here. So if you send a child off who's 2 or 3 years younger than everyone else at the camp, there could be a social disconnect there. And the second is even more important. You can force your kid to go to the math team a few times. You can force them to go to the math circle a few times. Don't force them to go to a summer camp. The most common reason I hear for students not liking a math summer camp is they didn't want to go in the first place and mom and dad made them go. So you can force them to these other things because it's just a few hours, and if they don't like it, they won't shut down. But if you put them through 4 or 5 weeks of something they hate, it's going to be hard to ever get them back to it. And a target for these people who are doing a lot of independent study, some of them will get really interested in research even down in high school. Even before they get to college, there are a series of competitions for these sorts of students who are creating research, independent research, well, somewhat independent research of their own. Now, one caveat about these is typically the winners of these things are almost always connected to a university somehow. So if you have a student who's interested in this sort of thing, you want to start exploring avenues to get them connected to some sort of program in their university. Now, some of the summer programs that I've mentioned do help put students on this path. But if they're going to get serious about this, you want to start looking at ways to get connected with various people at the university or with yourselves if you're a professor. It's often the way it goes. Now, after you start studying math for a while, you might get distracted. You might get distracted into some other area of intellectual math-related study. There are Olympiads, there are competitions for all of those. Not as many as for math, but math is typically the starting point where kids will then branch into other interests as they learn about other things. And I want to focus on the first one, or the first area here, computer science, a little bit. Mainly because it's been shocking to me over the last several years as I start to realize how few of my students program. And it's astonishing to me because in my generation, I think my generation was the top still. Now we're starting to get back close to it, but it was the top of people going into computer science. You know, when I was a kid, all the schools had computer labs, just like they do now, but when I was a kid, the schools also actually had computer classes, and they don't have them now. There are a lot of schools with computer labs and no classes because they can't find anyone to teach them. The other thing we had when I was a kid was, well, we had these computers. You know, you had the Apple IIc, the Apple IIe, and you had these computers, but you didn't have video games, right? I mean, this is one of the things you battle with a lot. Your kids want to play video games all the time. And I tell you, if video games were as good then as they are now, I might still be living with my parents. You didn't have video games unless you wrote them yourself first. Right? You turned on the Apple IIe and there was a blinking cursor, and the only thing you could do was write code. That was the only thing you could do with the computer. And that was great, and that's where a lot of my generation started with these machines. You know, in my perfect world now, these computers, if you're going to put them in front of a kid, would just have a big red button in the middle that says start coding. You click the button, and then they can't do anything else until they start writing code. But that's all been taken away, and the kids don't have good on-ramps. I mean, there are the things out there, like Khan Academy has some stuff, Code Academy, but the kids don't have on-ramps to those things. How do they find them? Whereas in my generation, they would find them because that's what the machine did. It's the only thing they could do. And a lot of parents are reluctant to put the computer in their kids' hands because of the video game thing, right? You're scared to death that they're just going to go off and play video games all the time, or you're scared to death that they're going to write code all the time. You shouldn't be afraid of that. Those people are very valuable, and they're typically very happy, you know, the people who do like to code all the time. And that's the first of the reasons I'll give you for programming, is it is a potential career. They're very in demand, and there's no group of people I've encountered to get to do what they want to do more than programmers. If they want to come in at 1 p.m. and stay until 11 p.m., they get to do that. Everyone else has to be there 9 to 6, but the programmers get to come 1 to 11. And why is that? They're hard to find. Good programmers are really, really hard to find. They're very in demand. I have a lot of companies coming to me to try to hire our students. And we have sponsors of some of our programs, and their goal is to get to our students. And when I say, what are you looking for? They say, programmers. Do you have any programmers? And then, you know, I'll say, yeah, we got some programmers. We got some decent programmers. I mean, we're mostly math kids, but we've got some programmers. And then they say, no, really, do you have some programmers? And it's only after asking for programmers 2 or 3 times, and then they start to ask for the math students. So you really can write your ticket, in a sense, if you really enjoy coding. But now, programming isn't for everybody. I mean, there are probably some programmers in the room, yeah? There are plenty of programmers here. But, you know, it's hard. It's hard to stay focused on code, stay in code 40 or 50 hours a week. There are a lot of people that, you know, they like coding a little bit, but they can't do it all the time. They don't have that level of focus or that level of interest. It does at least open up options within whatever career you choose. Because a lot of things, in a lot of careers, and this is going to happen more and more and more, you're going to need to be able to work with the machine in order to get better at what you're doing. You may not need to be able to write code all the time, but you'll come up with ideas, and you'll be like, well, if I could just do this, or I'd like to explore this thing over here, but somebody needs to write a little program. And if you don't know how to program, well, then you need to do something that's really hard. You have to go be nice to a programmer and get them to do it for you. All right? And that's hard. It's hard to go be nice to programmers, right? I mean, I'm a programmer now a lot of the time. I do some of the development work at Art of Problem Solving, and nobody likes to work with me when I'm programming. Because I want to do my thing, and I want them to leave me alone for a little while so I can get this done. But if you know how to code yourself, you can build the prototype. You can explore the thing yourself and move on. You don't have to go be nice to a programmer. And it will also expand the way you think about problems. You know, a lot of the really great problem solvers I know, and I talk to them about kind of their intellectual development, there was a significant step for them when they became good developers, when they became good programmers. They started thinking about some sets of math problems differently. I think about running Art of Problem Solving differently since I've retooled myself as a programmer over the last few years. It just makes you think about things in a more structured fashion. If you work on functional programming, it makes you think about just whole universes of problems in a completely different way. So even if you never program again, it'll be an experience unlike anything else you'll get in school. Now, the first step to succeeding in all these sorts of things, I've already talked about this a little bit, is developing the math skills. The list of the Olympiads that I put up there in the other disciplines, the students that represent the country at those events, a lot of them are typically art of problem-solving students, even though we don't teach most of those subjects. And that's because they built their foundation in math. And this is the place where a lot of these students self-identify first as being future scientists or future engineers, even if they're not going to become mathematicians. Now, I'll talk a little bit real quick about art of problem solving since I have a captive audience. How many of you are familiar with art of problem solving already? And we'll let that be advertising for the people who don't have their hands up. Thank you very much. I'm going to talk about a few things here real quick. The heart of our work right now are books, classes. We have an online school and a website. I'll start by talking about the books. And the first set of books that I co-wrote back in college, when I was finishing college, are Volume 1 and 2. And I know some of your daughters have used this to prepare for this event. I know I've seen at least one or two of them here today. And we wrote these. We'd started a national math competition when we were in college, and the scores were very low. So we had to do one of two things. We either had to make the tests easier, or we had to try to teach the kids. And we opted for something that's a little more rare in American education. We opted for option number 2, rather than just bringing the tests down to make the scores go up. And that was why we wrote these books. And then 10 or 11 years ago, we started the Art of Problem Solving company that you know of now. And we started building a curriculum that's written just for these students. So our target isn't everybody. We don't sit there and say, oh, we've got to hit all the state standards, because the state standards are too low for these students. And we're writing something directly for this audience. What we're really writing for is ourselves. We're writing the books that we wish we'd had when we were much younger. Much younger. Just gets worse every year. And now we've been confronted with another problem, which is, where do we find more students? We'd like to reach more and more students. So one thing we can do is advertise. And that's kind of a little bit of what I'm doing right now. But this is fun advertising, because I get to come here and tell you that your kids are awesome, and you're very receptive to that message. But another thing we can do is to build more students like those that we work with, and that's why we're reaching younger. We're developing an elementary school curriculum now, and we'll be taking that online over the next few years. Now, speaking of taking things online, we have an online school that was recently accredited. And this started in part because I tried teaching high school. When I got out of grad school, not out of grad school, I did not, when I left grad school after about a couple months, because that was not for me, I taught high school for the rest of that year because I thought I really wanted to be a teacher. I was 22. I'm 43 now, all right? And you can imagine what I must have looked like when I was 22, all right? The kids walked all over me. The first day I go in, I'm teaching, and they're all laughing. They're like, the new kid's pretending to be the teacher. I'm like, no. I'm really the teacher, you're supposed to listen. It was very hard because I thought all the kids were going to be like me and like your kids, and they wanted to be there. They wanted to learn this cool stuff, but it's not like that. It's not like that at all. I had one class like that, and it was enormous fun. And I had a few kids in the other classes like that, but it was very, very hard. So 10 years later, I'm messing around on the internet, and I start to think, hey, if we build a school, I can let selection bias work for me, because if I put up a sign saying, we're going to do math and it's going to be hard, then the only people who are going to sign up for that are the people whose parents force them and the people who really want to be there. And that's worked really well. We started off the first summer, we had 20, 25 students. This past summer, we had maybe 100 times that. So the school has really grown. We have a full curriculum now. We cover all what you would call the standard subjects, but covering all the good stuff in those subjects that you typically don't see in school. We're breaking out into computer programming. We have some specialty programs for students who are preparing for the highest level of competitions. This is our Olympiad training, and we've recently expanded into chemistry and hope to move into some of the other sciences for the Olympiad level preparation. The heart of our work, kind of for these kids, is the website itself. It's kind of a social center for the kids who really love this. We have over 150,000 people around the world. They get online. They're mostly talking about math, a little bit about video games, but they're mostly talking about math, sharing their experiences, sharing problems, learning from each other. And we have a bunch of other resources as well. And I'm a little embarrassed that I don't have a slide for it, but I'd like to talk about our foundation a little bit, particularly because we have the director of our foundation, executive director right over here, Dan Zahara-Paul, if you stand up for a minute. So I'm going to point out, Dan, and I'm going to, again, since I have a captive audience, I'm going to talk a little bit about the foundation because Dan's done some really amazing work over the last few years. We started a summer program. Well, originally we wanted to start a competition that was focused on underperforming schools in New York City. And Dan went into the schools and talked to the people there and talked to the students and parents and really researched the problem. And he came back and he said, no, what you really want to do to affect these students much more deeply is start a summer program. So that's what we did. The first was that 4 years ago now? Yeah, 4 years ago we ran our first program with 17 students. And it's for these kids, it's really a life-altering experience because some of these kids have never been outside the city, much less in an environment where the academic standards were set really high and they were exposed to things that most kids in the entire country will never see, much less the kids in their schools will ever see. But put in a room of kids who have shared social experiences with them, but also have shared intellectual experiences with them. And to see these kids grow. This past summer we had 80 students, is that right? And now we're looking to branch into, looking to go to other cities and build programs there. So if any of you have a particular interest in this or have organizations that want to get involved in working with Dan, you need to find Dan and talk to him more about that. So now that I've talked a lot about middle and high school, I'm going to talk a bit about college because a lot of the young women here are juniors or seniors and they're starting to make those decisions about where to go. And that's where I'm going to start, is talking about how to choose a college. And I'm going to focus more on things that aren't as obvious because they're the obvious things. There's cost, there's what do you want to study, and that sort of thing. The first is that the other students are more important than the professors, because most of their education will come from the other students that are in the school. Obviously, almost all of their social interaction will come from the other students, but these other students, they're going to open doors for you down the road. They're going to, if you impress some of the other students or make friends, they're going to create places for you. They might be business partners for you later. They might be spouses. I got my MRS when I was in college, and I tell you, that was by far the most valuable thing I got in college. So the peer group you're going to be embedded in is extremely important. Again, that's part of why you brought your daughters here. So when you're evaluating schools, going and seeing the school and seeing what the student body is like and saying, is this someone, are these people that I am like, is extremely important. And this is also very important. It's important in all the top tier schools, obviously, but even the different top tier schools have different personalities. You don't want to go to Caltech without having visited. And I put Caltech in that sentence very specifically. Caltech has a very specific culture. And if you haven't visited and don't already know that that's your culture, you could be in for a pretty rude shock. The students are here now, so they're seeing MIT. They're seeing some of the students. By going to the summer camps, if they go to summer camps, they'll meet students who are a little bit older and know where they went to college, and they'll have people to talk to. But learn a lot about the peer groups and when you're choosing a college. Now, one thing you're going to be confronted with is having to pay for college. And some places are definitely worth borrowing for. MIT clearly is. Your very top tier universities, typically they're worth borrowing for, mainly because of this first thing right here, is because of the peer group you're going to be exposed to. But also, these top tier schools definitely do open doors. The flip side of that is some aren't. And that's a cold, hard truth that obviously the schools aren't going to talk about a whole lot. But there are definitely lots of schools out there that have very large sticker prices that are simply not worth borrowing tons of money to go to. And for those of you who are considering the local private school that costs $40,000 a year, one question to ask yourself is, does anybody outside this town know what this school is? And if the answer to that is no, then there's a good chance that they're in this category. And you might want to start thinking about State U, which is going to give them probably the same education and cost a lot less. The last one's a little less popular, and that's go away from home. Now, when I was in high school, my mom, I had heard her say more than once that I was going to go at least 1,000 miles away from home to go to school. I wasn't so sure how to take that. That was a commentary on what I was like as a teenager. Her goal was that I would, grow up and actually figure out how to clean up after myself and get my own food. And my wife might have some comments about how well that actually worked out. But there was something too, I think what she really wanted me to do was grow up. And I could see that when I would come back during college, when I would come back to my hometown, and a lot of my friends did not go away to school. They stayed locally, they lived at home. And I had changed a lot more than they had because I had a lot more experiences that were different than anything I'd encountered when I was in school, when I was in high school, and they didn't. And I think there was something to what my mom was trying to accomplish there was, cut the cord and make me have to go figure things out for myself. And that's very important. I work with a lot of these students as they're going through college. I see them because some of them work for us at Art of Problem Solving, and I see them after they graduate. And there's some that really struggle to get out in the world. And many of them are ones whose parents did not cut the cord, who held them too close. And they have a hard time functioning and becoming independent out in the world. And so this is a message, if I get just one of you to hear this message and back off a little bit, I know this is not a popular message to some of the parents, but it will help them. At some point, you have to let them go and let them make their own mistakes. You know it's a mistake, but they have to make their own mistakes at some point. So I'll stop preaching about that. And we'll move on to what they should do, various educational options for them outside the classroom once they're in college. And the first is internships. Everybody knows about internships, but a very important thing here is to try different internships. When we say go try different internships, I don't mean Goldman Sachs and then JP Morgan Chase and then go into different industries. Don't just go from this research lab to this research lab to this research lab. Try several different things. Part of it is process of elimination. One of the things you're going to learn from an internship is, oh, this really is not very good. I don't want to do this. And that's valuable information because then you don't spend the next 3 years of your life aiming at it. But if you just stay in one discipline, you don't get exposed to these other things. Try a .com for a summer. Try your research lab at the local university. If you're interested in finance, there are zillions of finance firms that have internships. But make sure you try different things. The next is to run something. I don't care what it is. If it's going to be, be the president of your sorority, if it's going to be captain of whatever athletic team, be in charge of something. You need to find out if you're that person. There aren't a whole lot of people who are that person. Or that person who can step into a room and run the show for a little while. But the people who can do that are really, really valuable. And if you are that type of person, you want to start training at that as early as possible. And the only way to find out is to go in and try to run something. You may find out you're not that kind of person, and you want to be the person who's doing, who's mostly doing the work and not running the show, and that's fine. But you want to answer that question. And if you are the kind of person who can run something, get started early. Learn those skills, because there is something natural to it, but there are a lot of mistakes that you want to make while you're being president of the sorority and not while you're trying to build a company. And you should write something that's not homework. Because in school, when you're writing for school, we see this. We have a lot of us college students work for us as assistants in our classes. And even the ones at Fair Harvard are terrible writers. Almost every single one of them. And they all got 800 on their SATs. But the problem is, their classroom writing assignments, they're rewarded for using big words, complicated sentence structures, and they write stuff that is gibberish. Because gibberish, the SATs are graded by a computer. They don't know it's gibberish. They're just looking for the big words in the sentence structure. They don't have to write anything that's actually going to be read by someone who wants to read it. And that's what I mean by write something that's not an assignment. Even the English teachers don't want to read that stuff, but they have to. So write for the paper, write for a newsletter for whatever club you're in, write a blog on a website for people. Write something that someone else is going to edit and give back to you and force you to rewrite. That's writing something that's not an assignment. And then you start to learn that these complicated sentence structures really aren't that valuable. You want to write in clear, plain, simple English and get people to understand you. And then next is to impress someone. Maybe it's a professor, maybe it's someone you work for at an internship, maybe it's one of your classmates. But people open doors. I didn't understand this when I was in college. I didn't understand how grad school worked, how grad school admissions works in the sciences. They don't care about your grades. They care about the reference. And I didn't understand this until my senior year. I was late in my senior year, and my academic advisor came to me and said, "What are you doing next year?" And I said, "I have no idea." And he said, "Well, what about grad school?" And I said, "Well, the applications were due 2 months ago, and I didn't send any in." And he said, "Okay, MIT, It was MIT, Cornell, Minnesota, Berkeley, Stanford, Caltech. Pick the school. And I said, but the applications were due 2 months ago. And he said, that doesn't matter. Fill out the paperwork, I'll send in the reference. I picked the California schools because I was sick of cold weather, and got into them. And that's where I learned that the grad school application, that letter he wrote is what got me in. And there's a reason for this in grad school, of course, is that the professors, they're graduate students, they're their workers. They're their indentured servants, let's be honest here. And you want good indentured servants. You don't want bad indentured servants. And how do you trust when you're hiring someone? I mean, a lot of you in this room have to make these hiring decisions. If you have someone you know say that person is good, you don't care anything else about that person, right? You're not going to sit there and check their transcripts and call all their 8 previous employers. If someone you really trust says this person is the best we've seen in 10 years, you're going to go after that person. You're going to hire that person, and you don't really need to know much else. So impress someone, and maybe that someone will be me. We have a lot of math prize for girls. Alumni come work for Art of Problem Solving when they're in college, and a few of them have joined us after college. So we are as they're getting into college and they need some walking around money, need some pizza money, please have them contact me. We'd be very happy to find something for them to do. And they serve as great role models for our younger students. So now I'm going to wrap up a little bit. I've been talking a lot about strategies for the kids. I'm going to talk about strategies for parents. And the first is to get together, is to organize. Why is there all this stuff on the walls in the schools for the basketball team and the band and the football team? They've got booster clubs. And most of the best math teams I've seen have an army of parents behind supporting the coach. So get together. It's much easier to do the next step when you have other parents with you. And the next step is agitate. And we have a lot of students who want to take our classes in lieu of their schools. And the accreditation has helped somewhat with that. But the only thing that I've seen work is this step right here, is to just keep asking, keep pushing, keep pushing, keep pushing. And when I go into schools and give this message, I see the teachers and the principals in the background going, no, don't tell them that. But it's the truth. I mean, this is why the football team gets so much support. This is why the band gets so much support, is there's political pressure coming from the community. You're the community. And when these 2 steps don't work, there's the last one, which is do it yourself, is to pitch in. And that's part of what these booster clubs are and such, but we've seen this in San Diego. I've come from San Diego. I started a math circle in 2003 there. And after a few years, we had maybe a couple dozen students, and I went to the parents and I said, look, I'm driving an hour each way to do this. I would like to have a bigger reach. We've got a few more teachers, bring us some more students. So they went into the community and started spreading the word. And the next fall, they called me up and they said, okay, we got more students. And I said, that's great. Let me know how many so I know how many teachers to get. And they said, we've got 200. And I said, oh boy. Okay, now I need you to do a little bit more, which is run the thing. Because the math circle went from 25 to 200. I couldn't run that. So the parents took it over entirely. They have completely run it since maybe 2005. And the San Diego Math Circle might be the biggest in the country now. They've got multiple levels. They've got multiple subjects. And it's entirely the work of the parents. The strongest middle school locally won the California State Math Counts competition. Now, those of you who are from California know that this is a surprise. San Diego is not supposed to win state math counts, right? The Bay Area wins every single year since as long as anyone can remember. I mean, it's long enough that they stopped checking the scores in Southern California. All right? It wasn't until a week later that anyone realized that Southern California had won. So, but the group that won in Southern California was actually, it was a group that was started 8 or 9 years ago by a parent from the San Diego Math Circle who told me once that she's been looking for something for her son, looking for something like the Math Circle, something in the schools, but she can't find any schools that do this. And just kind of off the cuff, I said, well, why don't you just build it yourself? And she did. And she went in. I spoke at the school 3 days ago. It was a room with as many people as are in this room from a single middle school to help build their program. And they got good enough that they won the California state competition, which has never happened out of San Diego and hasn't happened out of Southern California in 10 or 15 years. And then the coach went on to win the national competition, which you get an asterisk when you're coaching California, but because obviously California has a lot of talent. Now, while these parents get involved in this initially because they're trying to help their own kids, they typically stick around for a few reasons. First of all, it's enormous fun. It is enormous fun to work with these students. They can do amazing things. And they're just people you want to be around. But second is you're doing something more than when you're helping them than just helping them. See, technology lets us reach out and affect more people with just the efforts of a few, more than ever before. Just a small number of people, and you put computers with them, they can do things to reach the whole world. This wasn't possible 30 or 40 years ago. Now you can get just a small handful of people and do really, really amazing things. And the thing is, we know who a lot of these amazing people are that are going to make all the scientific, mathematical, intellectual, economic advances in the next generation. We know who they are. They're over there in a room somewhere taking a test right now. They're your children. And when you're investing in making their lives better, you're investing in making all of our lives better. Thank you very much.
Thank you, Richard. So now we have several questions for you from the audience. There were actually about half a dozen parents that wanted to know, can you give this talk to my kids? And I just want to let those parents know that we're going to have this presentation available. The video as well as the slides will be available on the Math Prize for Girls website after today. Okay, so we have another question. This parent wants to know, many students who excel in high school math competitions don't go on to a career in math. Is that a problem?
It's fantastic. It's absolutely fantastic. When people ask me, am I disappointed when my students don't go off and become mathematicians? My answer is I'd be very disappointed if they all did, right? We need people who can think about these complex problems and solve really hard problems that they haven't seen before everywhere. Everywhere. It's not just in math. It's not just in the sciences. It's not just in medicine. I mean, what we would give to get some of them in Congress. But we need some of these people. We need these people all over. I think these are very broad-based skills. We teach math because I think it's, for many people, the best route to learning how to solve hard problems. But I don't think of myself primarily as a math teacher. I think of myself primarily as teaching problem solving. And these are the critical skills. Math is a great conduit. Math is also the place where kids first self-identify and where you can start to separate them and say, okay, here's something interesting, and kids will get really excited about it. So I think it's fantastic when they go off and do other things.
Okay. So we have another question. This parent wants to know, first of all, wants to let you know that this was a really great talk.
Thank you.
And wants to know, is it crucial that my child go off to one of these leading universities? What's your opinion?
It's crucial that they find a peer group that is outstanding. So no matter what school you go to, there's going to be a group of students somewhere within there that is somewhat like MIT. It's not going to be as big a group. It's not going to be as easy to find. I mean, at MIT, you have a hard time avoiding it. But it's essential that they find a peer group that will challenge them. If you're the smartest person in the room, you need to find a different room. And that's one of the dangers of you go all the way through an average high school and you're the best, always. And then you go to a kind of an average college and you're the best, always. You're not getting ready to deal with the people who are here. And that's something I certainly saw. For me, it happened in high school when I went to the Math Olympiad program. I went to the Math Olympiad program. This is what you get to after you pass the AMC tests. They take the top 24 students. And I made it my sophomore year. And I was quite sure I was awesome. I mean, I knew everything. I was the best in my state. I was going to go be the best in the country. And I walked into the first class. And the first class, 5 minutes in, I had put down my pencil. I didn't understand anything the professor was saying. Nothing at all. And I spent 5 weeks being completely bewildered And I talked to some of the other students very shyly because you don't want to admit that you don't know what's going on. And that was a huge mistake. And that's one thing I try to say to the students when they're in the room is, you have to ask questions. Because the people I know who are really amazing, they ask some of the stupidest questions you could ever imagine being asked. And when you dig a little bit, you find out they're actually really smart questions. So you have to get over that. But I almost lost track of what were we talking about? So the key is to get into these groups where you're going to see people who are just way better than you are. Some of them will be role models. Some of them will be friends. Some of them will be targets for you. People you're going to try to chase down. So it's not essential. If you know you're going to go to grad school, it's even less essential that you go to a school like this, right? Like it's the last school you go to that's often the most important. So if you know you're headed to grad school, then going to State U and then heading to Stanford or heading here or whatever, that's a fine plan. Now the thing is about grad school is don't go to grad school unless you know why you're going. All right, it's not a great default choice. Get out in the world and start doing something. If you have no idea why you're going to grad school, then you may hate it. You may not finish, but while you're sitting there spinning your wheels, other people are moving along. The world is moving along. And if you don't know why you're going to grad school, you're probably not going to be one of the strongest people there. It's not always true, but you're probably not going to be one of the strongest people there. And the academic crowd, if academia is your goal, you have to be one of the best. The academic space is absolutely crowded. When I was at Shaw, I was there for 4 years, we would interview a lot of people who went to grad school. And the first thing I would ever ask a PhD person is, why are you here? And if their answer was, I couldn't get a job in academia, that was a bad sign, right? Because that was saying, one, it was saying, I don't really want to be here. And we don't want to hire people who don't want to be there. And two, it was saying, I wasn't one of the best. And that's something to keep in mind. It's not a great default choice. But sometimes you do actually know when you're a junior in high school that I'm going to go into research. I'm definitely going to do that. That's who I am. And you as parents, you can know, particularly those of you who are in research, can know, are they right? Because some of these kids, it is pretty obvious. I get to know them when they're 15 or 16. They're not as into contests, but you know that they really have a love, a passion for the subject. That means that they should be really immersed in it, like you get to be in academia. And then it's not as important that they go first to this school.
Okay, we have another question. That's a parent wants to know, many math competitions besides this one are really dominated by boys. How do we encourage girls and non-Asians to participate?
Those are two hard questions. I think the Math Prize for Girls is already doing something very important, which is for the women is to show them that there are others who are interested and they won't be alone. And there's even research in this area. So Glenn Ellison has done some of this research he's got 3 daughters who are fantastic at mathematics, one of whom is in this competition. And what he found, he looked at the people who are at the very top of all of these competitions. And he found that the girls overwhelmingly came from, I think every single one came from a school that had a lot of high-achieving kids. So it might have been every single one or all but one, but it was a really striking number, whereas the guys came from all over. There were a lot of guys like me who were the only people in their school who was really into this stuff. And it's hard not to look at that and say, there's a clear gender difference here, right? That having a crowd is really important. Having a crowd of other people. It's harder for whatever reason. I don't know if it's societal or if there is actually a genetic thing. It's harder for a woman to say, I'm not going to care about what any of these people say. I'm going to do this thing right here. And for those of you who have both daughters and sons, you probably see this in your own home. You may see this attitude more. You see a lot more of these girls. It's not that uncommon for a boy who's doing really well in these competitions to have B's and C's and everything else. It's much more rare for girls to have that. The girls who are good at this stuff tend to be good at everything. Really good at absolutely everything. A lot of the guys are too. But for a girl, it's a safe bet. We go over and grab any of the girls in that room and say, what's your grade in English? The answer is going to be A or A+. And it's only going to be A if the school doesn't give A+. Whereas if this were the USAMO and you just went along 12 USAMO winners, I mean, 1 or 2 of them aren't going to be graduating from high school. But they're going to get into MIT anyway on the strength of their math. So part of it is just is that. Part of it is creating events that are less time sensitive. So I know that that's one thing. When I talk to young women about math competitions, some of them just don't like competition, don't like the one-on-one, I'm going to beat you. And of course, guys like that. And that's, or not all guys, but many do. I mean, that's why video games, poker's even more dominated by guys than math competitions are. So there's definitely some of that culture. So finding things that are more cooperative, things that are less time-based will help. But the idea of we want to get more women on the IMO team, the IMO team's not that important. You know, that I don't know that that's necessarily a sign of success. What I'd be more interested in doing is finding more avenues for kids who are excellent at mathematics to exhibit their excellence and to get around each other. So I would actually, instead of trying to get more of these people into competitions, I might want to find more ways to get these students together and to get them participating in something. Now, for the non-Asians, that's another really hard problem. I don't know what the issue is there. I mean, and it's like this everywhere. I looked at a list of the top 100 students on the Canadian competition. This was 8 or 9 years ago, but I looked at the list there, and there were 100 names on it. There were, I counted, there were 88 that were clearly East Asian. 88 out of 100. There were 11 that were clearly Eastern European. You know, names that look like mine. There was only one. There was only one that was not in one of those two categories. So my first approximation is there was only one kid on that list whose parents were born in Canada. And, I mean, part of it is cultural, right? And part of it is, of the Asian people who have come to this country over the past 2 generations, there's been an incredible selection bias. And we've gotten some of the very best people out of China, out of Korea, out of India. These amazing people have come over. And so one of the things I like to talk about in this vein is, I think the biggest, I don't know if it's the biggest, it's certainly in the top 5 impact 9/11 had on this country was 9/11 happened about a few weeks before the H-1B visa program, the expansion sunset. So I don't know, how many know what the H-1B is or came through on? Yeah, so a lot of you know what the H-1B, the H-1B is how we get smart people in this country, right? I mean, it's a visa program that's for outstanding technological people, math people, science people, and the cap went from like 65 up to 185 or 195. I found this out the hard way because when I was at Shaw, I had 4 guys working for me. The year that the H-1B cap first got hit, 3 of them needed an H-1B visa and got deported because our HR department wasn't on top of it. So I learned about this the hard way, so I know a lot more about this than I ever care to. They expanded it from 65 up to 185, 195. 9/11 happened. There was a sunset provision on that. It went back down to 65. There's an extra 20 for people from like Chile or something like that. But it dropped back down to 65 and hasn't changed since, because since it happened right after 9/11, no politician was going to touch immigration, right? They were not going to say, oh no, we need to get this number to go back up, because we're talking about students, which is a bad thing to say then, and we're talking about bringing in foreigners. And so you look at that, that's 65 to 185, that's 120,000 people a year for 11 years of the best, smartest people in the world that we're saying can't come here. Terrible. So I think that's part of what's been going on with the huge influx of Asians into math competitions. How to get other people involved? I don't know. It's just, I mean, at some point the parents have to be looking at it and seeing, well, wait a second, they got to look at the job lists and see geeks top to bottom too, but yeah, I don't know. And it's a very difficult issue.
Okay, so this parent wants to know and says, you know, sometimes the top universities and math competitions can put a lot of pressure on kids. If you have a kid who's sensitive to that, do you have any advice on how to help them handle the social pressure?
Yeah, that's hard. I mean, and part of the reason you put them in these situations, like the Math Prize for Girls, is failing here is not a big deal. It's a big deal to them. They'll go home crying, and that's okay. Failing in their first year of college is a big deal. Having them quit when they get to that's extremely expensive. That's expensive in the sense of their future and their self-worth. Getting them to understand that these competitions aren't that important. It's hard because it's part of your job as a parent to get them, to try to enable them to make them want to succeed, but then to pull back when they don't succeed and realize that really this isn't that important. It's not that winning isn't that important, I should say. It's important to participate, it's important to try, it's important to learn, but failing here isn't going to close doors the way that failing in college will. So that's one of the things here. Now, in college, it gets a little bit different because there it does start to get important. The main thing to stress there is when they are struggling, they need to speak up as early as possible. And that's one of the hardest things for students who are at this level. They're used to being the one everybody comes to with questions, right? Like, I'm the one everybody asks questions. So when I went to the Math Olympiad program and I had questions, I'm like, wait a second, I don't know how to do this. I can't do that. I'm the one that has all the answers. And to get them over that it's really hard. It's really hard to have somebody say, I need help. And part of it is to get them, that's one place where maybe having me talk to the students does actually help, is to relay my experience at MOP and to say, I really didn't know what I was doing. And to understand who to go to. I think this is actually an important life skill. Is in my company, I'd say one of the things I'm good at is matching people to problems. Like if I don't know how to do something, or if this person doesn't know how to do something and needs to know, I know that person knows it, and I put them together. So it's an important skill for the students to learn, is when you need help, who do you go to? You don't just want to go to anybody. You need to figure out who to go to. And this, those of you who manage people know this as well, that these sort of matching problems are really important. So that would be one thing to encourage them, is try to get them to understand everyone hits the wall. This happens to everyone. They won't believe it. If they can talk to peers about it, or people who are older at summer camps is another way. Everyone hits the wall. Everyone hits something they don't know how to do. And it's better to confront that earlier, but everyone does it, and they have to learn how to go find the help and get through these things.
Yeah. Thank you. Yeah, and I imagine that praising the effort is also really important, as well as taking the risk. So if you never fail at something, maybe you're playing it too safe.
Yeah, that's definitely true. If you never fail, you're definitely not aiming high enough. That's absolutely true. And the effort thing is also, there's even research around this as well, that if you praise someone for doing well because, you must have worked really hard to succeed to get that's more effective or more effective for what you want them to do on younger kids than saying, you must be really smart. Because then the obvious thing later when they fail, they define it as, I failed because I'm not smart enough. And smart is something you can't change, but effort you can.
Okay. So this parent wants to know, what recommendations do you have to allow high school students to see what real math is like? Even math contests don't really simulate real math.
Real math? What's real math? That's hard. If they want to see how math is used out in the world, one of the difficulties is that they're still pretty far from the math that is used at the very cutting edges of, these high-tech companies, or, within security stuff. If you're going to go look at the kind of stuff that security companies are working with, like internet security, that's using some pretty advanced number theory. One of the things they're going to have to do if they want to see what real math is like, they're going to have to start programming. Because that's where a lot of this stuff is going to get used. It's going to be applied. It's going to be, they're going to be on a computer. They're going to have to learn statistics. And not just that baby AP statistics course, but really hardcore, hard stuff. Internships are a great way to do this. I don't know that you can do it so much in high school. It's a hard thing to do in high school. In college, they'll get to some of the edges of it and get in internships and be around people who are actual practitioners. That's probably the best way. Math circles help with this some, because math circles, you'll see people, there will be professors who come in and present things that are close to their research, hopefully brought to a level that the students can actually understand it. If they have friends that are in labs that are interesting, that's another good thing. Like if you could bring them into the media lab here at MIT, they may not actually see the actual mathematics that's going into it, because that will take a long time to go through, but to see what's coming out of it is really interesting. I don't know if that was a great answer, but it's the best I have.
Okay, so this parent says, you know, an average home in the U.S. focuses on football and CSI. How can we help change this culture and get math to be more of a bigger focus?
When you succeed at that, I'll buy you my third Ferrari. How do you change the culture? I don't know. Like, it's a strange. Well, first of all, one thing you have to change is the idea that people are comfortable saying, I was never very good at math. Right? I mean, that's a badge to some people. I don't like math. I wasn't good at math. Like, you can't imagine them ever saying, I couldn't really read. That's unthinkable. I mean, does the Big Bang Theory help? It's not clear that it helps because, you know, they sit there and they portray the math people as these kind of not quite right people. And you know what? Some of them are not quite right, but that's true of everybody, you know? Like you sit there, I've gone sometimes to a math camp and there'll be a basketball camp right next door, and you know what? Those kids are just as geeky, right? 15-year-olds are geeky. That's what 15-year-olds are. I mean, people who are really immersed in something are geeky as well. Like the best basketball players are geeks about basketball. The best musicians you know, wow, what a bunch of weirdos. And it's fine. They're rich and interesting people. Part of it comes from this culture, right? That you don't ever put people on screen and call them math people who are anywhere close to normal. How to get it to change in the broader culture? People understand the importance of this. They look at those. I mean, one of the things that's hard is in math, you look at the top math, all the best jobs are math. They're all geeks. All the most fun jobs are math. They're all geeks. And one reason it's fine to lionize in school, it's safe to lionize the football players, is you know that they don't have a future. Right? I mean, some of them do. Some of them do. Like, I think there's a role for sports to help. You know, there are a lot of things that sports will teach you. But even the best football players, very few of them make it to the NFL. And so there's no jealousy really wrapped up in a parent, you know, all watching these kids, and oh, these kids are great, they're really good football player, but deep down inside, it's not threatening. It's not threatening. It's not like these kids can do something I can't do that's actually valuable. But a 14-year-old who can do something intellectually that I, as a 43-year-old, know that I can never do and is really valuable, like that 14-year-old can probably do my job better than I can. That's threatening. I don't know if that's part of what's going on, but it's part of the difficulties of pushing this more to the fore and say, these kids are important. You need people in positions of power, people with microphones, you need politicians to stand up and say, not that STEM is important, but that the best kids are important, right? Why do people want to be football players? Well, there are role models. There are heroes out there. There are these people at the top, these pinnacles to point at. Who are the role models in the math world? Right? Who are the role models? Who are the people that they're aiming at, the kids that are aiming at in the math world? They don't have that sort of thing. Society hasn't produced and honored these people. To the extent they have, I mean, one thing that has helped change this is Bill Gates, Sergey Brin, Larry Page, Mark Zuckerberg. You know, these people are starting to be held up as role models and as heroes, and they're geeks. And I think that has helped. You know, if you look at the graph of computer science majors over time, or percentage of people who are interested in computer science, there's a huge spike in my generation. It goes down, then there's a huge spike in 1999, and then the crash happens, and now it's starting to climb back up. And it's all because of this. So I think this is helping some, but I think that's part of it, is to create these sorts of role models for these kids to go after.
Yeah, very true. And by creating these kinds of forums, summer camps and online forums, you're also giving these kids an opportunity to socialize with other like-minded kids, which will also help with social skills.
Yeah, once you can get them there.
Yeah.
That's the step, is getting them there is hard.
So this is an AOPS question.
Okay.
Do you have plans for a Skype or Google Hangout type of video, live interaction-based problem-solving class? Right now, you have only text-based ones at AOPS.
Yeah, the sort of number of problems with going to a video audio base. First of all, probably half to 2/3 of my teachers would quit. The teachers don't want to do it. They like the interaction that we have now. Like when I'm teaching, I can see a lot of what's going on. Like there's a lot of things the students don't see that are going on, that are, all the students are talking at once and they're coming into a teacher, and I can really air traffic control the room really well when everything's coming in as text. Kids process text much faster than they process audio and video. So this website that I was part of, they polled the students and asked them, they said, we're going to be interviewing all these really good scientists and really good mathematicians. Would you like those interviews on video, or would you like them in print? 98% said print, because they can scan it, they can read it so much faster. Audio and video are simply slow. If somebody sends me a link to a video on the internet, if it's not more than 15 seconds, chances are I'm not going to watch it. All right, chances are it's probably just a cat doing something silly, so I'm not missing anything. But even if it's something interesting, I'll sometimes, if I know it's something interesting, I'll answer, hey, do you have this in print? And these kids are the same way. They're jammed for time. They want to consume the information faster. The print also allows kids to, so one thing in a lecture, if you go to a lecture and the professor says something and you miss it, it's gone, right? It's gone. Even if you're recording it, well, if you go back and hit the recording, then getting reoriented when you zoom back in is hard. When it's all there in text, you can just scan through and pick out the things. Now, I know this medium doesn't work for everybody, but nothing does. And then there's also the technology problem. You know, we're going to have, this coming Monday, typical school day, we'll have, I don't know, 300 or 400 students connected online. If you're doing audio video, well, you know what Skype's like. If you do Skype 400 times, how many times is it going to fail? It's definitely double digits. And so there's still, the technology's not there, but I'm not even sure it's a good technology for what we're trying to do.
Okay, and there's some questions here. Can you say something about your main competitors and some of those resources, Khan Academy, for example? And also there's a question here about why not a physical school?
Okay, so I'll take the first one first. I mean, Khan has a very different target than we do. So I went up and visited Khan Academy last summer. It was very interesting. Sal is remarkably charismatic. You know, I can see how he's been so successful in getting so many people behind him. But their target is everybody. You know, I don't know that Khan Academy is a great target for these sorts of kids. I mean, it's a fine thing for them when they're young. You know, they can sit there and play with the thing and play with the problems, but the problems are still too easy for these kids. And they may be changing that. I'd say they've come in an enormous way. So when people first started asking me about Khan Academy, my answer was, let's see in 5 years. You know, it's way too early to tell, because what they are now is not what they're going to be 5 years from now. And I think that's still the answer. They've got some amazing people working for them. You know, a lot of my students have gone on and done internships to work, or now working at Khan Academy. So I'm excited to see what they end up producing. But they're producing something that's very different. Khan Academy, there's no live interaction. You know, that's one big difference between AOPS and Khan Academy. We have a community, and when they're in our classes, they actually interact with live teachers. You know, they're going to work with me. They're going to work with Dave Patcher. They're going to work with these people. They're going to have someone they can interact with, and that doesn't happen on Khan Academy. And that may be something he changes, but at his scale, I don't think he can. Right? He operates at a much different scale than I do. Now, physical schools is an interesting problem. We've had a number, actually, even private equity people come talk to us about starting these sorts of schools. And it's one of those things that, and I'm really scared to say this on a video that's going to be on the internet. But I've said a lot of other things I shouldn't say in a video that's going to be on the internet, so I'll keep going. It's one of those things it's something we might do someday. It's finding the right set of people that will be able to do that within our structure. We don't, like within our company now, we have a lot of balls in the air, but finding the right set of people that can make that happen. The hiring problem is very difficult because the teachers in general are so important. And when you have these schools, you've got to get the right people in the room. And we have a very hard time finding the right teachers even for our online school. And there we don't have the restriction of you have to live in this place, whatever this place is. So we're starting to get a handle on that problem. When we feel like we've got a good handle on that problem, then it's not inconceivable that we start looking at more physical centers.
Very good.
And I got a lot of people back in my office that if they watch this video, they're going to be like, you didn't just say that.
Okay, we have some questions about internship opportunities at AOPS. And a parent wants to know, do you hire mothers to work for AOPS?
Well, for the mom, do you program? You want to move to San Diego? San Diego's really nice. We are definitely hiring. For the interns, we have a lot of people. We've had a lot of Math Prize for Girls participants work for us as assistants and graders in our online school. And then we've had, this past year, we had Lu Yi. Some of you may know Lu Yi came out and worked for us over the summer. And we've had a couple of them join us full time as well. So yeah, we've got plenty. They'll work for us during the year. They can, over the summer, I mean, all the work can be done remotely. So a lot of them will just work a few hours a week. Some of them will treat it as a full-time job over the summer and work a full 30, 40 hours a week. So we have plenty of stuff for them to do. What's that? Oh, all they have to do is send an email to jobs@aops.com. And we start hiring the interns as they're finishing their senior year of high school. And there'll be an email sent to, well, I shouldn't run ahead of myself, but I'm going to ask Ravi to send the email he always sends to the alumni, inviting them to come work with us.
Okay. And there's a question here as well about your summer program.
My summer program? Oh, the foundation summer program. Okay. Dan, do you want to answer it?
Let's hear the question.
That was it. Can you tell us a little bit more about your summer program?
I'm going to invite Dan up here because he built it. He's also an MIT alum.
Okay, great. So, I have a natural teacher's voice, so it's very hard for me to speak to a large audience and be quiet. So the program is a program for underserved New York City middle school students with talent in math. We're trying to create a realistic pathway for them to become scientists, mathematicians, engineers, programmers, and so forth. And so what Richard was talking about this ecosystem of opportunities that students can be a part of and their independent study and summer programs and math circles and so forth, we try to create the bridge for our students to then become a part of those communities and join in these same programs themselves, beginning with the summer and then afterwards with our own follow-up throughout the year. So we're essentially trying to be the informed parent who guides them through this process, who helps them with scholarships and whatever else they need. Ranu told me that that they're in particular becoming involved. I will say that we are always looking for counselors. We hire college students to work at our summer program. It is paid. We cover travel and room and board. It's great. It's a lot of fun. It's a very interesting environment to be in. And so we're always looking for counselors, and we also hire instructors for those who are past college to work there during the summer. And it's a very interesting group of students to be with.
Thank you. I just want to say here, there are also some questions here about MIT, about the different majors and some of the resources at MIT. I would guess that you don't want to speak about that, Richard.
Yeah, I'm not the right person to ask about that.
But what I would say is that if you've gone to any of the info sessions that the admissions office has held for Math Prize for Girls alumni, you can ask there. You can also send them an email. The admissions office loves our contestants here, so just mention in your email that your daughter was a Math Prize for Girls contestant, and I'm sure you'll get.
Yeah, there's one thing I will add. We're having a session on the AOPS site October 6th. I think it's a Monday. They come onto our site every year. It's been for about 10 years now. Matt McGann, the head of admissions there, another admissions officer, and they'll bring one or two professors. They come onto our site for an hour or so and answer as many questions as they can get through during that time. So that's another place that your daughters can go to ask questions about MIT.
Okay. There's one last question here, and then I'm going to open it up if anybody would like to ask a question directly. There's some questions here about majors. Do you have an opinion about what majors are better than others?
I majored in chemical engineering. That was a tactical error. So I majored in chemical engineering. Part of it was, oh, you got to major in something that's going to have jobs. And of course, by the time I came out, there weren't any jobs in chemical engineering because chemical engineering was one of these. That was a good thing for me because I didn't want to be a chemical engineer. I mean, part of it is figuring out what your targets are, like what you actually want to do later on. Like if you're going to major in English, I mean, if you're going to major in English, you better have a target of business school or law school or something that's actually going to be useful later on. I don't want to belittle the English majors in the office, in the room, but I mean, if you're going to come to MIT and major in English, you've really made a mistake. But that's what I mean when you got to think about what the next step is if you're going to be majoring in the English history and these sorts of things. That the next step there probably is not going to be as easy as it is if you're going to study computer science or if you're going to study physics or whatever. If you're going to whatever you're going to major in, get some coding skills because that's going to be one of the biggest barriers to getting a job, even if you study math. So if you're a math major and you're pretty good at math, whatever you're going to interview for is probably going to be related to computers. You're going to need to know how to code. You may not be programming all day long, but that's going to be a wall for you. Pure math majors, the job outlook for pure math majors is, I'll be honest, is not, I mean, it's not what it is for people with actual technical, specific engineering skills, specific computer science skills. Now, if you're very good, if you're off the charts good, then you get to pick what you want to do. But it's harder to do that out of the arts than it is out of the sciences. Now, within in the various disciplines, I mean, one of the main things I would recommend is make sure it's something they actually like. You know, if they don't major in engineering just because there are jobs in engineering, if you absolutely hate engineering, you know, even if you get through the major and get to the job, like, if you're not going to enjoy it, try to go find something else that's in the maths and sciences, if you are a math science person, that you will enjoy. And if you're not in the maths and sciences, I don't have a whole lot of recommendation, mainly because that's really what I know is the math and sciences. But if you're not going to be in the math and sciences, then try to be stapled to something close. Like if you like writing, you know, writing about math and science, or doing something that, you know, I see a lot of these people, they end up being recruiters for math and science companies, you know, like if you look at the recruiting offices at a Google and as such, a lot of them are very smart people who can talk to geeks, but they aren't geeks themselves. Some of them will eventually hire themselves into roles within those companies. That's another path.
Okay, so let's open up the floor if anybody else has a question that they'd like to ask directly. Sorry. Why don't you just speak up?
I just wanted to know in majors, computer science versus computer engineering, what's the advantage, disadvantage, and what's the difference?
I'm not even sure I know the difference, to be honest. Like,
is one better than other? Or?
I don't know, because I don't know the difference, I don't know well enough to answer the question. It would probably matter more on what school they're going to and the other people they're going to be around. My guess is computer science sounds like something more that you're aiming for a research position. You're not going to be actually hacking away. You're less likely to be. So computer science, you know, when you talk about computer science, a computer scientist can actually not code very much. You know, computer science can be much more of a mathematical position. And I would guess that computer engineering is much less likely to be like that. You know, that's going to be more, I don't actually know what computer engineering even means. It might actually mean infrastructure, building the computer. I think it's better depends on the student. Like what is her inclinations? If her inclination is actually thinking deeply about the algorithms and such, that's going to be more towards the computer science side. And you know, look into what the problems are the computer engineers are solving to see if that's it. Either one of them is going to be fine. Like, to be honest, it's hard to say one of these is actually better. They're going to be okay. They're both going to be probably better off in the long run than, say, comparative literature. Sorry to the comp lit people in the audience.
I had a question notice any kind of active discouragement of women going into extremely mathematical fields? The reason I ask is that my daughter had an experience just about a week, 10 days ago. Yale University visited her school, and one of the professors was the one giving the talk, and afterwards there were students lining up to ask about research opportunities. And the boy ahead of her, when he asked the prof about research opportunities, he said, "There's so many things we can do and all that sort of thing." And when she went and asked essentially the same question, what the prof said was, "Yeah, quite an extremely high amount of mathematical knowledge. Why don't you do medicine or something?" So, do you see that a lot?
You have to take that with a grain of salt because it's Yale. He was asking if I see, well, first of all, he noted the Yale professor who was kind of dismissive of his daughter probably because she was female. And that was my derisive comment about Yale. I like to make derisive comments about Yale. Again, sorry to the Elis out there. I know several, well, maybe 3 or 4 good people that went to Yale. But he was asking if I see a lot of active, I would say, discrimination against women in the maths and sciences. How old was this professor?
Sure, but must have been in his 40s or something.
No, so that's old. I mean, I'd say you see it less generationally. As you get younger, you see it less. I'm sure it still exists. But there are a lot of organizations out there that are trying very hard to bring more women in to these fields, and not just because it's the politically correct thing to do. You know, there is certainly a lot of political pressure, globally speaking, to address women's issues, but also because these companies realize that that women contribute something very different to the culture than men do. They simply do. For one, frankly, I think the guys behave better. You know, if you have a room full of guys, it can turn into a frat room, particularly when they're 22. You know, if you have a room full of young guys, but if you have a mixed room, everybody behaves better and works together better. And I think companies have seen that. You know, companies have seen that when a group goes from 95% guys to 60% guys, there's a better dynamic in the room. And so I think that's part of it. But it's going to take the younger, newer companies that are going to drive this. And academia is not a younger, newer company. So you're going to face this. I would guess you're going to see this more in academia because you're going to see more people who are not used to having female intellectual peers, not to put too fine a point on it. They're not used to it because it doesn't happen in their industries, whereas in a lot of other industries, you know, it's happening more, it's happening faster. Academia changes very slowly.
Yeah. And that's why we really need more female academics. You'll see, by the way, Dr. Priya Natarajan at our program later today, and she was the first tenured female physics professor at Yale. She has a lot to say about that subject as well. So, okay, one more question.
So you talked about culture, you mentioned Caltech. Can you tell us a little bit about the differences in culture and what we could expect at different universities or in general about cultures?
I'm pretty removed from the various schools, so I can't say a whole lot about the very specific places, but some of them are much more focused on the hardcore geek culture than others. Caltech's at an extreme. MIT is obviously also at an extreme. I don't see it quite as much or hear quite as much. Like what I hear coming out of Caltech is the most extreme that I hear of anywhere. Like there's Caltech and then there's everything else. The students I know that have gone to Caltech either absolutely love it or really, really despise it. You know, there's some in the middle, but when I say despise, I mean leave the school. And I don't see that happen very much at any of these other top tier schools. MIT obviously has Harvard right around the corner, and there's a lot of mixing between the two groups, and that may soften the MIT, that culture a little bit, but also MIT is bigger. I believe MIT's a decent amount bigger than Caltech. You know, a lot of these, so Princeton, for example, has a decent sized engineering school in math and physics, but it has an enormous rest of the school. and that rest of the school, makes it a very different place than say this is. Stanford's in California, and it actually does make a difference. Stanford it's a bigger school. It's much more outdoor than these places are. So that's part of the culture you're going to look at is what do the people do when they're not in school? Where do the people go? So Stanford, a lot of the people, it's a natural pipeline. Stanford Startup or Stanford.coms. It's becoming more of a pipeline from some of these other schools, MIT, Carnegie Mellon. But Stanford, if your goal is the .com world, Stanford's closer to it because it's right there. So that's another thing to look at is where do they go when they're leaving the school? Like if you're going to go to Goldman Sachs, Harvard's a natural pipeline to Goldman Sachs, right? And if you look at the list of where do Harvard people go, banking, consulting, it's a very common thing. So that's part of something to look at is where are the students that are coming out of these schools going to get an idea of the culture. But the best thing is simply to go visit. In some of them, and when you visit, try to expose yourself to lots of different student groups. Because if you go for an actual visit where you stay for 3 days with a student, the tendency will be that you'll be mainly influenced by the people that you're actually staying with. Try to expose yourself to more than just that group of 7 students or whatnot.
And now we also have quite a nice network of Math Prize for Girls alumna at the various schools, and so encourage your daughter to reach out and contact another girl maybe a few years ahead of her and see what her experience has been at that college as well. Okay, maybe one last question, and then we should let Richard go. Yeah.
So I have a question about really how to develop the girls' interest and pursuit of intellectual challenges in the form of a mentorship. Right now we talk about like peers and all that. In the form of mentorship for the girls in middle school, do you think it's a good idea to bring some older like mathematicians or teachers to stimulate the interest or lead the way?
Yeah, I mean, for middle schoolers, probably your best bet is the high schoolers. So if you have a middle school, and it's one thing I try to encourage when I have students in the room is if you're in high school, one of the best ways to learn more math is to teach it to the middle schoolers because whatever it is you don't know, that's what they're going to ask about. They just sniff it right out and go right to it. So they're going to respond more to that than obviously they're going to respond to you going in there as a parent, right? They're going to attach to these. Or for young women, if you have a 12-year-old girl who sees the 16-year-old girl at high school who's doing all these amazing things and clearly tracked to come to a place like this, that's a great role model. So if you're in a place that has a pipeline of students, now not all places do, but if there's a pipeline there, I think that's a good place for that sort of relationship to form. I think it's hard for a 12-year-old, I don't know this for sure obviously, but it's hard for a 12-year-old to see a 38-year-old as a mentor or as a figure, but I think the high schoolers, that's not as true. So I think high schoolers can start to think farther ahead, start thinking about, 12-year-olds not thinking, I don't want to be a baseball player when I was 12 years old, and look at me, I'm not playing baseball. But, I thought it could happen. I'm glad it didn't, but, so I think that's, pairing middle schoolers with high schoolers or even with college students is a better bet than trying to bring in a mathematician. Because also, you're going to have a hard time. One of the things that's hard is when you're bringing in mathematicians or even math circles, and why it's rare to find a good one or find good teachers is as you get separated more in age, you forget what it's like. I can be pretty childish, so I can teach a 13-year-old, but not every 43-year-old can. Can really remember and relate to what it's like to be 12 or 13. So when you're 12 or 13, and 12 or 13 is a really hard time. So you have a 16-year-old who definitely can relate to being 12 because it wasn't that long ago. That can work really well.
One of the things that we're also seeing is that a lot of Math Prize for Girls alumna are actually leading the way. And so we haven't studied this, but we're finding that once we have one alumna from a school, we then see many more coming from the same school. So, encourage your daughters as well to be mentors because they really learn a lot about leadership and and then we see more girls involved in this.
Yeah, this dynamic is really important. So I mentioned from Alabama. I was the first, there was one other kid that year, but we were the first ones from Alabama to make the Math Olympiad program might have been ever. They're taking 24 from the whole country. You're not expecting to find many in Alabama. The thing was, I was fairly social when I was in high school at the math competitions, and I would talk to a lot of people. So a lot of people knew me, and when they found out I made the Math Olympiad program, they were surprised. They were like, I know Richard. He's not that smart. If he can do that, I can do that. And for the next 10 years, Alabama had 1 to 3 people in this camp of 24 people. And so this is part of what you're saying. And what you're seeing there is when you see someone close to you do it, and they're not someone who's far away, they're not someone that's at a remote, but someone that you interact with every day, and you see them do stupid things, you start to think, well, I actually can do that. I can do what that person can do because I've seen them in action, and I can do those things. So that's another part of getting them together with the high schooler. The relationship goes the other way as well.
She actually had a relationship with a smart high school kid, and that works out wonderfully. So.
Perfect, yeah.
Okay, well, thank you very much for your attention. Thank you, Richard, for a wonderful and very stimulating talk.